Alright, so now we will continue with the my decision tree. We have some brackets that have been automated wonderfully, which I didn't want. They have set all the brackets like this, which I didn't want at all. So I'll try to fix that. I don't know how to turn that off, but there must be a way to turn off the auto formatting. I tried looking for it before, but I never found it. Where did that go? Okay, I'm just trying to move that down. And here we'll put that bracket down here. I don't really like my brackets like that because if I'm looking, I don't want to look diagonally, I just want to look up and down. Some people may find it easier that way. Personally, I don't. So I'm just going to fix it. Put that there too. I don't know how it did that because I had them like that initially. I did put the computer on sleep for a little bit, so maybe it did that when I jumped back in. Move that one there. It's still a little bit messed up because I had these on the next line like that as well. That like that. That like, whoops. That like that. Move that down there. Now they're all off anyways. Stupid thing. Yeah, stupid thing, man. There we go. So auto formatting doesn't even work properly. That's one of their setbacks of IntelliJ, that it does that. If that's not your style, then it can become a headache. That looks alright now. Just maybe a few more we'll just move down. Some of them are going to be off now like this. Wonderful, we'll just leave it like that. Just a bigger headache to try to fix it. There we go. That's one more here. Alright, so now we will have another method here called fill tree. So we can try it out just to do a little bit more practice. It's a little bit of a long one again. It's basically doing the same thing. We could have maybe set these as the strings and just passed them in, but I didn't. So we're going to write out the strings again just once. And we're going to fill, so this is a traversal here, so I think we can, so what it does is, it's a brute force traversal. Fill tree, I really just think it's just filling the tree, but forgot exactly if it does just find the nodes of the tree, if it sets a path or prints out all of them, so we'll find out in a sec. This one is a choice, so it adds the nodes when you select them. So the names are a little bit off. Maybe I could have just made this method and called it selection or something. But anyways, we'll just come down here, so that's the add node method. We'll go below that, and we'll say public void fill tree. And here we'll say tree dot get root element. Then we'll say binary tree node of generic type. Not generic type. We'll do string. We'll do the same thing, current node. Points to tree.root. Binary tree node of type string. Call it temp root. So an object reference variable, one is a current node which points to the tree.root, and one is the temp root. And here we'll say current node dot set right to new binary tree node of type string. So we're going to set the current node, which is pointing to the root. So we're going to set them all manually like this. I think this is just going to fill all it's just going to fill the whole tree. So I think instead of being able to make choices, it's just going to show you all the options. So we'll say current node dot set right to new binary tree node of type string. We'll say have you finished all the assignments? Question. So that's the right child of the root. Excuse me. Here we'll say current node dot set left new binary tree node of type string. Then here we'll put another string into for the elements. So we'll say did you complete comp 1, 2, 3, 1? Should have had a question mark on that. Great, now it's not even going there. What's up with that? It does that often for some reason. Must have hit something. It must be a shortcut on my keyboard that like changes it to the multilingual standard, whatever that is. Some kind of like the Latin alphabet or whatever, something like that. Changes it to like another language. So here we'll say, so now we have our set left. So we have the set left to did you complete comp 1, 2, 3, 1, and our set right to have you finish all the assignments. And the root node. Where's our root node? So perhaps the root is already set. Gets the root element. Do we set it above here? I don't think we did. Because this is in the add node. Okay, actually maybe we did because we said if tree.root is equal to null. So we'll test it out. If not, we can change it if there's a mistake. So we have current dot set left. Then here we'll have temp root points to current node. Temp root points to current node like that. Then we'll say current node points to tree.root.getRight. So we're going to do a little bit of method chaining here. So we're going to say, okay, well, current node points to tree.root, and then the get right of the root. So it's a kind of like an advanced method chain, or like a variable chain to a method. Instance data chain, an instance data call from the object to chain to the method. So it's handy techniques. Again, we could have used getRootNode.getRight, but either way works. If it was encapsulated, if it was like strictly encapsulated, then we could have said here tree.getRootNode and then said .getRight with the parentheses on the getRoot node. Both ways work. So current node points to tree.root.getRight, then we'll say current node. So we may get lost trying to think of it in our head, so we'll just keep going here. Current node dot set right. I'm just gonna put my mouse on the current line so I can try to find it if we get lost. So current node. Here we'll say current node dot set right. Whoops, current node dot set right to new binary tree node of type string, and here we'll have current node.getRight. What happened to my flashing? Stopped. So current node.getRight. Sorry, current node.setRight. Did I say get right? Okay, so current node.setRight to new binary tree node of type string. Have you finished all the quizzes? The string is have you, or the element have you finished all the quizzes. And under that, we'll say current node.setLeft. Set its right child, now we're going to set its left child, so set left to new binary tree node of type string. And the string is going to be, have you finished assignment 1? So have you finished assignment 1? Question. Have you finished assignment 1? Actually no, sorry, is it have you finished all the quizzes? Then yeah, have you finished assignment 1? Question, semicolon, next line. Then current node points to temp root. We'll say current node points to tree.root.getLeft. Current node points to tree.root.getLeft. So we're going to do another method chain. We're going to say, okay, well, current root. First we did the get this to the get right, and now we'll do the same thing to the get left. So we'll say current node. Current node. So current node points to tree.root.getLeft. Then we'll go to the next line. We'll say current node.setRight. So current node points to tree, to the tree.root, so to the root of the tree, and then .getLeft, and so to the tree's root left child. And we'll say set the right of the left child to set the root's right child of the left, root's left child, so we'll say current node to tree.root.getLeft, and then we'll say current node.setRight, current node.setRight to new linked new linked binary tree node of type string. Did you like JavaFX? So that's going to be the element. Did you like JavaFX? Question mark. We'll do a semicolon on the outside, then we'll say so that was a set right, then we'll say current node.setLeft to new binary tree node of type string. We'll pass the element here as a string. We'll say did you complete comp 1131? Did you finish comp 1131? I remember when I went to I live in Canada, but in Vancouver area. But that's in BC, British Columbia. I went to school in Arizona for a little while. I went to BYU for a little bit. Just took a credit class there. But in Arizona, I was going to school there for a while, like a couple semesters. I remember the abbreviations for the classes were only 3. Like Chem 151, Electrical Computer Engineering 175. But in Canada they use 4 digits. I don't know if that's standard or not. Anyways, we'll continue here. We'll say current node. So we have current node.set left to did you complete COM1131. We'll say temp root points to current node. I went to the University of Arizona, not ASU. Reason is because I always lived in Canada, but in 12th grade I went to, in like the middle of 12th grade, I went to boarding school. In Utah, I went to like a program. One of those like programs for like troubled youth or whatever. Kind of like a disciplinary school. Like we could just like work out and study, that's it. So I think I just decided to stay in the States for a little bit longer. After I came back, I went back and then came back again. Just a little story on me. So then we'll say so temp root points to current node. They weren't too big about Java when I was in the States though. I noticed in the electrical computer engineering curriculum, it's different than computer science, but it seems like electrical computer engineering is a little bit harder than computer science. I don't know why it was like that. Maybe it's just more old school. But they taught us C. They didn't teach us Java. But now Apple's getting rid of C, so maybe that's going out of date. We'll talk about that stuff later. So temp node points to current node here. So we have current node.set left to did you complete COM1131. Then we have temp root points to current node. Then we have current node points to current node.get left. Current node points to current node.get left. Then we'll say current node.set right to a new binary tree node of type string object. Why is that in quotes? So new binary tree node of type string object. Then here we'll say get left above. Here we'll say finish Linux and C. Then under that we'll say current node dot set left to new binary tree node of type string. New binary tree node of type string to whoops, what's wrong with that binary? Oh, this should be a Y here. Binary tree node of type string, and here we'll say finish comp 1131. Finish comp 1131. Then current node points to temp root. They still use C++. Like Microsoft uses C++ and C#, I think. But it's a lot different than C, like just a few things are similar. So current node points to temp root. And we'll say current node points to current node.get right. They use C++ in a lot of game design, apparently. So here we'll say current node points to current node.getRight. And I heard that a lot of car programming, auto programming, they use C++ too. So current node points to current node.getRight. Whoops. Current node points to current node.getRight. And then we'll hit enter here. And we'll say current node dot set right to new binary tree node. Of type string. We'll say learn Java SQL. Funny story related to coding. I finally learned that Java had a use. I was like, wow, you can. Someone finally told me, like, or like I learned that you can use Java for Android. And then, well, then I also found out that like Kotlin and Java are like they're interchangeable, so you can use either or for Android. And then Android requires you to learn like XML, something markup language like HTML. And then I was like disheartened about that because I was like, oh well, for Android, you can use Java to create Android apps, but what if I want to create my app for Apple too? What am I gonna do? So then you're like, oh well, I have to create a whole nother code in like C. I don't even know if you can create it in C anymore. They created Swift now, so they're trying to get rid of C. So you basically have to learn a whole new language called Swift to do it. So I was like, well, how's that gonna work? So you have to know both and create two codes. Then I did some research and I found out about React, JavaScript, React Native, so you can create one app with one code on and deploy it on multiple devices, different kinds of devices. Then I was like, well, okay, Java's useless, Android's going to be useless. Then it was like, then I found out at the end, well, you can use XML and React. So I was like, oh, okay, so it's like half good then. So learning Android will be, if you learn Android, you'll basically know XML, and apparently you can deploy it on React. We'll be doing those videos a long time later because we still have to do JavaScript first. And that's what I'm kind of working on right now in school, so I'll be making those videos in a while. Not too long. Maybe at the end of this year. We still have a few video series to do, like Android, then we have C and Linux, and then we have Python and C#, but I might do the JavaScript before the Python and C#, so we'll talk about it. So it's coming up soon, probably this year. Sorry, like next year, 2022. So we'll say current node.setRight to new binary tree of type string. Then we'll say learn Java SQL. Then here we'll say current node.setLeft, because we have set right, then we have set left here, so we can put so learn Java SQL. Then we'll say set left to new binary tree node of type string. Then we'll say learn JavaFX. So Kotlin's just like an easier version of Java, basically, which uses lambdas like JavaFX. So it's pretty similar to Java, honestly. It's interchangeable, so you can use converters. You can write like Kotlin and convert it to Java, and if you want to write Java, you can convert it to Kotlin, or you can just use Java. So it is cool. We'll be doing that stuff coming up after this video series. And we won't be using Kotlin, we'll be using Java and XML, I think. So we'll say current node.setLeft, and I think we'll be using Android Studio as well. But you can set IntelliJ up to, we might try using IntelliJ, so we'll see. So we'll say current node.setLeft to learn JavaFX. Then we'll say current node points to tree.root. And temp root points to current node. temporary points to current node, then current node points to current node dot get right. Current node points to current node dot get right. Then we'll say temp root points to current node. The temp root points to current node. Hopefully I'm not doing these doubles. So then I'll say current node points to current node. I was so happy when I found out you can use Java for Android. I was like the happiest person in the world. Then when they told me I couldn't use it for iOS, I was like, oh no, what's the point? Then I have to create two codes. So current node points to current node dot get right. Then we'll say current node dot set right to new binary tree node. Binary tree node of type string. Which says finish the labs as the element. Then of course I found out you can use XML for React Native apparently. And then I was kind of happy again. I was like, yeah, it's gonna be helpful. It's gonna be worth it. So current node dot set right. And then we'll say current node again dot set left. Current node dot set left to new binary tree node of type string. So I'm learning Android stuff right now, and I'm making this series. And then when I almost finish that, I'll start posting the videos. Yeah, so new binary tree node of type string. And we'll say here finish the quizzes. So finish the quizzes. Then here we'll say current node points to temp root. So current node dot set left. Finish the quizzes. And we have current node points to temp root. We'll say current node points to current node dot get left. Current node points to current node dot get left. Then we'll say current node dot set right to new binary tree node of type string. And we'll say finish assignment 2. Then below that we'll have current node dot set left to new binary tree node of type string. So we could have instantiated the nodes above and just passed in the name perhaps. Doesn't really matter. On the fly works good too. So we'll say finish assignment 1. And then semicolon return. So it should be good. It's probably an error somewhere. And that's it. I also had some traversals for this, but they're recursive, and I've already given you the code for that. You can go through them. Not sure if this actually works, if this toString was actually necessary, but we'll just do it anyways. This is from my assignment. So we'll say add override. Whoops, what happened there? Add override. Okay, did it again. Oh yeah, I know what it's doing. So it's saying add override. And it's telling me if I want to import it from HTML. No, I do not. Okay, so override public string toString. Then return tree.toString. So it's going to call the built-in toString. I'm not sure if it actually hits this method, just in case. And also how to get root node. we can do that as well. I'm not sure if we actually use that. I'm not sure why actually we'll just leave it at that. We'll save it. We'll go to our main method. Let me just open that file and have some water. It's been about half an hour now. All those great stories I have. I know they're not boring at all. Oh yeah, so I will remember to put my Facebook there. I don't have a Discord, but if you do have questions, I'll try to answer them. Or if you want to if you're if you make trading bots or something, or if you're interested in that, just hit me up. I don't have Instagram though. We didn't have that in high school. I had one, but I deleted it. I don't really like it, but now you can use it on Messenger. I just deleted it before that, but didn't really use it that much. I have a Twitter, but I just use it to check out some analysts, financial analysts, or sometimes I look at Elon's crypto tweet. Not really too often, but if he makes a tweet, he made a tweet on Tesla, saying he was gonna dump it. It already looked like it was going high. I didn't have a chance to do a video on it, but he tweeted it. Sometimes I follow financial tweets and whatnot. I don't think I have any followers on there. Maybe just a couple. I don't even use it. I just kind of ghost it. Just go on there and check and turn it off. That's about it. I think the last time I actually used it before I looked at Elon Musk's tweet was when oil was really low, after the pandemic, when it sunk down to $10 a barrel or something, $20 a barrel. I checked out OPEC's Twitter about the meetings just to get some information on that. That's about it. So here we'll just create a main class. You can pause the video if you haven't created it. So once you do that, then we will import. Actually, no, we're not going to import anything. We'll have to throw file not found exception. Actually, no, we don't, because I have my decision tree, and I have the decision tree we did in the last video and my decision tree in the same file, so I'll just skip down to that part. I have tries and catch. You can add those here. I have main method. Then I have try. Well, we can just do it just for some little bit of practice. So we'll have try here. Whoops, no, down here. So I have try. We'll open a bracket. And then below here we'll have catch. We'll do those later. So here we'll have my decision tree. We'll create a my decision tree object. My decision tree. Name it tree. We'll set it to point to new my decision tree. No constructor. Yeah, we had no constructor in that class, so we're just using the default constructor, which is just going to set up our instance data. So we'll say tree.add node. Maybe it should have been called nodes. And then we'll just print a new line, and we'll just test that out. So save and run that. So errors here, nope. So save and run that, hopefully it works. Oh, sorry, it probably won't work because of the catch. Okay, it won't. We have errors as well. So here we'll just catch something. We'll catch a null pointer exception. We'll call it E. We'll just say e.print stack trace and e.get message. We'll just system.out.println. null, whoops, null pointer occurred, the 2 R's, semicolon. Save it, run it. More mistake somewhere it looks like. Missing a parentheses. Line 176. Current node points to current node.getLeft. Parentheses. This is outside the string, so we'll it's outside the string, so we'll just save that and move it over, or the other way around. So are you in comp 2231? We'll just say yes. Have you finished all the assignments? We'll say no. Had you finished assignment 1? We'll say yes. Finish assignment 2 and a decision set. I thought there was more levels in that, but that's okay. We'll hit play. We'll just do all Y's and all N's. We'll say yes. Have you finished all the assignment? Yes. Have you finished all the quizzes? Yes. Finish the labs. Okay. You're in comp 231, we'll say no. Did you finish assignment 1? We'll say no. Stop printing out the Linux and C, JavaFX and stuff. Did you complete comp 1? Okay, so there we go. N and Y, we'll try N, Y, N. There we go. So it looks like we have all of them. Sorry, I just moved the mic for a sec. So we will go to main, and we will probably set a breakpoint here. We'll start debugging just to see how the nodes get set up. So my decision tree points to new my decision tree. We'll step in. So public class. Oh yeah, so after this video, by the way, we will do some rotations. I forgot to do that. We'll do the rotations on our original link binary search tree. And we'll do a couple of those. So why is it putting the brackets like that again? Seriously? Okay, so we have our public class my decision tree. It's going to set root to null. I think it glitched out, so we'll just stop. Because I moved a space down and then it's like, okay, where are we? So we'll re-debug it. So we'll step in here, whoops. My decision tree points to new my decision tree. So, sorry, let me just re-debug it again. You can keep it where you are. I keep clicking around and losing where it is. So, okay, so it's my decision tree, it's here. We're going to step into the constructor, if there is any. There's not. It's just saying we're going to use a default constructor. So what it's doing, it's instantiating a decision tree. A decision tree instantiates a linked binary tree. So we're going to go into the linked binary tree class. This is a default constructor because there is no constructor, so we'll step in. So here we're creating a linked binary tree of type string objects. We're naming it tree. We're pointing it to a new linked binary tree. Excuse me. My nose is getting stuffed. So we'll say we'll go into our linked binary. Excuse me again. Might have to blow my nose. So linked binary tree will go into the constructor here, the one with no parameters, because these brackets are empty. So we'll find the one, as we said before, the one with no parameters. It's not that one, it's not that one, it's this one. So every linked binary tree has a binary tree node root, which a root has a element and a left and a right. T element and a binary tree node left and a binary tree node right, and every binary tree node left has a T element and a binary tree node left and a binary tree node right, and so on. So this root here, binary tree node root, we're going to set it to null, and its left and right children are going to be set to null as well. So we'll step in there. We have root right now, it's null, and it's still going to be set to null. We're just going to explicitly set it to null. Mod count's going to get set to 0. Root set to null. Did it glitch out there because it was already on there? So then we'll step in again. We're done with that. We'll create a scanner. Happen there. Okay, so we created a my decision tree object. That was it. This is the default constructor here. I actually don't use the default constructor too often, but it just showed us how it works. So it's just going to go to the class and go down to the instance data and then set it up. Usually there's like a constructor here, right? We have like a public my decision tree takes parameters, but we don't. We could have had one, but we don't. So now we're going to step into the tree.add node method. So we'll create a string user string, which points to y, or it's equal to y, the string y. Here we go, user string points to y. Has some memory locations for the value and stuff. Hash stuff, hash 0, some other stuff. We have a scanner, no scanner. Yeah, we do have a scanner here. Set at memory location 1099, I think that's what it says. So we'll say while user string dot equals ignore case y or n. So while user string equals y or n, which it does, because user string equals y, step in. We'll say binary tree node string current node points to tree.root. So binary tree node of type string object. So it's an object reference variable named current node. It points to the tree.root location. So let's go this tree root is currently null. So current node should be set to null at this time. Right there, current node is set to null. Then we'll say if tree.root is equal to null. So if tree.root is equal to null, which it is, because tree.root is equal to null right here. Right there we can see in our instance data. So we'll step in, it's true. Tree.root is then pointing to a new instantiation of a binary tree node. So we have binary tree node root somewhere, right? Now we're going to say tree.root points a new binary tree node of type string. We're going to pass it an element. So what's happening here is that we're going to go to the binary tree node constructor. So here, binary tree node. The one with the the one that just takes one element. So binary tree node here. Public binary tree node, the one that just takes one element. So we have one here that takes, we could have had an empty one, but we don't. We have this one that takes one element, and this one that takes 3 elements. So we're gonna go to the one that just takes one element. Does it actually go into there? We'll find out here in a sec. Yeah, it does. So we're here. So the element is RU in comp2231. Go to the constructor. Element is RU in comp2231, the parameter, T element. We'll set the element, the global element of the binary tree node to point to the parameter RU in comp2231. Step in. Left is going to be pointing to null, and right child is going to be pointing to null. So a node is created with just a root. Then here we'll say current node points to tree.root. Sorry, it's moving around a little bit. So current, not sure if you can hear that staticking on the mic, because I don't have my the foam on it, the noise cancelling foam or whatever. So we'll say tree.root points to, so where are we here? Tree.root points to a new binary tree node. That's just the same thing. Step in, done. So okay, so we'll say okay, tree.root. Can I get rid of this watches first? So this tree root points to RU in comp2231 here element. Right there. It's a string, so it might have some more data than what the ints usually have. The integers. The integer objects or whatever. The wrapper class for int. So we'll say current node, which currently points to null, points to tree.root. So current node, so tree.root points to, root points to 1136 memory location. Now current node also points to 1136 memory location. So we're doing this again, I think current node and temp for the parent, like kind of like we did before in the find node and find max and stuff. I never actually went through those because the video was taking like 6 hours, but they were pretty straightforward methods. We did everything except for those, so hopefully you could go through those yourself if you were following those videos, the previous tree videos. So we'll print out RU in comp2231 current node. So here root was set. Now we have a pointer to the root. Now we're printing it out. Can I print it out at the same time? Guess not. Here we have RU in comp2231. Press Y or N. Now it's waiting for user input. A user input, so we'll just say yes. We'll hit Y and then we'll hit enter. Go back to the debugger. Step in. So what happened there? We were here. It's waiting for input. We executed the if statement. If root is equal to null. We executed these statements. Or in comp2231 it asked us. Then it waited for user input. We gave it user input and then it was finished. So if, why is that there? Then we have else. Okay, it's kind of messed up, but we have else all the way down here, and that's our while loop. So after the while loop, hey, it's going to loop back up, and I think that's where we are now. Is that where we are? It's not really sure. Are we down here? Yeah, we're down here, so we're going to loop back up. While user string dot equals ignore case y or n. So I think if you type exit, it'll exit. sure if I actually if I set it up that way. You can. So while user str dot equals ignore case y or n. What do we have here? Y or n. Okay, so user str. So I'm just starting to zone out here. So user str points to y. So this condition will be true because it says user str either equals to y or n. While user string equals y or n, well, that's true because it does. It's either y or it's either n. It's y, so either or work. So we'll just step in. We'll say, okay, current node points to tree.root. RU in com2231. That's memory location 1136. If tree.root is equal to null, well, tree is a root null. It's not, so it's false, so these brackets will get skipped to here. So else, and then if user str dot equals ignore case y. Well, did we select y last time? We did. So we are in com2231. Then we'll step in binary tree node of type string. Node 2, so we're going to instantiate a node here. Points to have you finished all the assignments. So have you finished all the assignments? It's going to be called node 2. Right here, element, it has a value of 1231, 1213. So it's set up a little different compared to the integers, as I said. The element is just set up to have an instance data called value in the string class, I guess. So we'll say, okay, that doesn't say anywhere node 2, but maybe it will in a sec. So we're going to go to the constructor, the binary tree node again, the one that takes one element. Here you go. Have you finished all the assignments? I think that's what it just said. Have you finished all the assignments? Then we'll do the same thing as before, set the global element to the parameter left to null and right to null. Done. Our node's done. Our node should be sitting here somewhere, node 2, at memory location 1211. Have you finished all the assignments? Its element. It should be sitting at the one we just said a second ago, 1213, unless that changed. We have our value in here anyways. It's our string. We know that's our node. Think of a little circle or a little square or a little box or something. It's holding our node. It's holding our element, our string, and we're calling it a node. So right now it's kind of just sitting on its own. We're going to link it because we're using links. I think we still have to do the array. Actually, no, that's in the heap. So we're going to do the linked heap and then the array heap after. So we're going to say here, current node dot set right. So current node, RU in com2231. That's the root. It points to the root. 1136. So we're using current node to set it up. We could have said root dot set right, but we're just going to use current node. So we have this root tree, and then root 1136, and we have current node pointing to 1136, so it's pointing to the root. We're saying, okay, set the right child to node 2. Set the right child to node 2, set right. So we're going to say the right child here, the instance data, binary tree node right, which will have an element, a left and a right. It's on its own. We're going to say set right, so it's going to take a node as parameter. So here we're going to say, okay, well, set right is going to take a node, which is node 2 as parameter, a binary tree node as parameter. of type T, then we're going to say the global right is set to point to the node. We could have set this dot right. We could have maybe said it actually. Yeah, we could have maybe said right here, right node or whatever. Right, it works. So done. And we can see here our root, his left child is null and his right child is have you finished all the assignments, and its children are null. Okay, so now we'll say current node points to current node. Dot get right, so current node is going to point to that new child, have you finished all the assignments. So get right is just going to return return the right child. Then we're going to say, okay, well current node, I think we just executed that. So then now we'll say here current node has changed. We'll see that here. Have you finished all the assignments? We'll print it out. Console here, have you finished all the assignments? It's waiting for, is it waiting for input? Yes, now it is waiting for input. Because it says the application is running, it's waiting. Maybe it could have said that it's waiting for input. But here we'll just say Y. So we got our debug data back. Then here it was in the same block, so it's a if and then a nested if. So if user string dot equals ignore case Y, so we have our global user string. Our local user string set to Y. So if it is Y, then we'll say user string dot equals, if user string dot equals ignore case Y, so if user string dot equals Y, which it is Y, which is true, so it's going to enter these statements here. The binary tree node of type string object. Binary tree node of type string object, we're going to name it node 3. Excuse me, so we're going to instantiate a node here. We're going to set it to a new binary tree node of type string and pass in the element have you finished all the quizzes. So we're going to go to that constructor, have you finished all the quizzes, everything's going to get set up as we said. Excuse me, so our node's going to get set up here. So node 3, where's our node 3 right here? Have you finished all the quizzes? It's holding the element have you finished all the quizzes, so it's going to say, okay, well current node, we're just pointing to the root right child. We're going to say, okay, we'll set the roots right child, the roots, so it's current node is pointing to the roots right child. Then we're going to say, okay, well current node, take the right child of the roots right child and set it to node 3, have you finished all the assignments? Set right, and we'll just jump through that. Then it's going to traverse again a level lower, so current node points to current node dot get right, it's going to shift again. Current node was changed to have you finish all this quizzes. This says assignments. I meant quizzes if I said assignments. So have you finish all the quizzes, then it's going to, same thing, set it's right. So have you finished all the assignments, its right child will get set to have you finished all the quizzes. Then current node points have you finished all the quizzes. Then prints it out. Did it print out already? Nope. So we'll just check out here our new root, or the same root and its new children. So here root, right, have you finished all the assignments? Have you finished all the quizzes now? And then null and null. What happened there? So we'll print it out here. You can see have you finished all the quizzes. Then we'll step in. Now it's waiting for input again. We'll say yes just to make it easy. And if we hit ends, it just does the same thing, just sets them to the left instead of right. So if user string dot equals ignore case Y, we will step into that. Then we'll say binary tree node of type string object. We'll name it node 7. We'll instantiate a new node, and the element it's going to hold is finish the labs. So we're going to step into that constructor. It's going to set up our node. We should have a node 7 down here. Or not have you finish the labs, just finish the labs. So current node, which points to that, it's highlighted in the blue. It's going to set its right child to finish the labs. Current node is going to set to current node dot get right. So to the new node, finish the labs. So it won't get set to null, it will get set to the right child. Its right child should be null. There you go. So it says system.out.println. Finish the labs, end of decision set. There we go. And break. So there you go. So we have everything here. Finish the labs. Can I get back to that last node? So root here, right. So of course all our decisions are yes, so we're only going to have right. We're only going to have our tree set to right children. So we have a root, or even comp 2231. So you can make this into a diagram if you want. You can fill the whole thing with all the nodes. That's what I did when I was practicing. And when I initially made the tree, I had written them all out. So I'll try to actually include that diagram, because I have a diagram somewhere. So we'll say here root points to RU in comp 2231. Its right child is have you finished all the assignments. Its right child is have you finished all the quizzes, and its right child is finish the labs, and that's done. So there you go. And now we're going to do the fill tree too. Let's see, where is it at? My decision tree, fill tree. So it's the same thing. What we're really going to do is just, instead of setting some of the nodes, we're going to set all of them. Current node points to tree.root. Temp root current node dot set right. How you finish all the quizzes. Current node dot set left. Temp root points to current node. So it's going to be like, okay, well, temp root is really the parent, so just set a pointer to the parent. Then current node points to tree.root. Yeah, so we'll do this. We'll probably do it right now. Are we done here? We are. We just maybe have the diagram. Maybe I'll just include the diagram in the comments. So maybe let's just go into that right now quickly, so we can just finish this. So we'll go to main. We'll go here, tree dot fill tree. We'll just click run. We'll stop and rerun. Okay, I didn't want that, but it did compile, so that's a good thing. So we'll move our breakpoint there and just click debug, save and run that. Alright, so we will just, where's our debugger? So we'll jump into that. What happened to that? By the way. Okay, so it's asking us for this data. Maybe I'll just hit Y's all across. Do we really need that stuff? Maybe I'll just try commenting it out. Start debugging. Or do I need to, I think I might have need to set up the decision tree first. Yep. There we go. It has to call the default constructor to set up the tree. So my decision tree, first it has to instantiate the object first to set up the tree, because to call the method, to call the method fill tree, we need to have our object set up. So that's why we need to keep that line, of course. Then we'll call our tree object, of course, and then use the dot operator to call the fill tree method. So now we will jump in to that method. We'll say tree, so tree.root is equal to null currently. Is that correct? Might have been a mistake on my part. Okay, maybe I might have a mistake here. My decision tree. Okay, we might have to call the add node method first. Let's just try that. We'll debug that, try again. Just hit while across. Step in, there we go. Okay, so yes, we do, unfortunately we do need the first method to get the root, because it has a tree here and then has the tree.add node. So the root was set up in the add node method, because a global variable tree.root is accessed through here. The root is set up in here. We have our length binary tree, right? And we said tree.root is set here. Then we're gonna say, okay, we'll get the root element. Tree.get root element. Then we'll say current node points to tree.root. So the root is already in com2231. So I think it's just, sorry, I'm just moving the mic for a sec. It's just gonna say, it's just gonna reset the nodes. It's gonna reset the strings even if there's a node there. I'm not sure why I did it like this, but excuse me, falling asleep again. So it is basically just gonna reset the tree. And this time I think it's just gonna add all the it's gonna fill the missing places in. Plus it's going to reset the nodes that are already there to what they already are. So we'll just set so we'll create a binary tree node object reference variable here to point to tree.root. Current node points to tree.root. Or even comp 2231, so we have here memory location 1132, and current node points to memory location 1132. So then we'll say current node dot set right. So we'll say current node dot set its right child to have you finish all the assignments. Excuse me. So it's just gonna see it already is that, but it's going to we could even take those out in this case, but every time we traverse the tree it might just be different options. So all it's going to do is just overwrite this node and put a new node there, right? That's all it's going to do. So right now it's node 1157, then we'll set right to a new node. So there we can see 1157 got set to 1167. So it's really the same thing, just holding this, holding a different, it's the same thing holding the same string, just a different memory location. So now we'll say current node which points to root, that is the same, 1132, 1132. Then we'll say current node dot set left. So current node points to the root at memory location 1132. Set its left child, which is currently null, to digicomplete comp 1231. So set left right there, it's highlighted in blue. We're gonna maybe step in just to, okay, maybe we should have just stepped over it. Left points a node. Then here you can see digicomplete comp 1231. Digicomplete comp 1231, and that's given its own memory location. Right there, also updated up there to 1170. Then here we'll say temp root points to current node. So temp root points to current node. Let's see here, temp root points to current node. So we just set the left. Now we're saying, okay, well, temp root, what was current node? Current node points to the root, right? 1132, root is 1132. So we're going to take a pointer and point it to the pointer, which is pointing to a root, so I hope that doesn't confuse anyone. It's just a pointer pointing to the root, because current node points to root, and we're saying temp root points to current node. So we're setting a new pointer, we're going to save it. We're going to save that pointer in temp root, and we're going to shift current node to point somewhere else. But temp root still has the pointer pointing to current node, that's how it works. So there we go, we have temp root points to 1132. Where is temp root? Temp root 1132, and then we have current node. Current node points to tree.root. So tree.root.getRight, so current node will point to 1167. Right there. Then current node dot set right to have you finished all the quizzes. Current node dot set left. Right. Then current node points at temp root, so it's a traversal. This is my own traversal. There's no name for it. There's no exact. There probably is some kind of like some kind of symmetry to it, some kind of symmetrical fashion. But I just did this on the fly, so I was like, okay, set a root to the parent, then shift down, and then okay, go back to the parent, and then go to the left. So it's like okay, go to the. So it's like okay, go to the right. Right. So it's like root, set the right, set the left. So initially it was like set right, then set left, then shift to tree.root.getRight. So get the next levels, the right child, right? Then it's gonna set those right and that left, and it's like okay, we'll go back to the initial right child of the root. That's what's happening. But now we're going back to that pointer so we can get the left child of that root, right? So same thing. Current node, which points to 1132. So current node points to tree.root. Tree.root.getLeft. That's memory location 1170, and this string are you in comp 1231. So points there. So it's like okay, well current node set the right, because current node now points there, and it's like well, okay, set the right child to did you like JavaFX, set the left child to did you complete comp 1131. Then it's saying okay, well set a pointer to current node. Oops. Then it's like okay, well set a pointer to the current node. Shift temp root to point to current node. Now current node shift to the left. Set the right and left child. Current node go back to the temp root. Now shift to the other side of the tree from left to right. Point to current node. So current node points to itself. Get right. Set the right and left. Current node points to the tree.root. Temp root points to current node. Then I just do some different stuff and traverse it just the way I want to. You can do that too. Same thing. And done. Sorry, so maybe we'll just try to get to the last part of that. So we'll just hit Y here. Go all the way down here, maybe to like this line. Okay, so it's like, okay, we have our tree here. Tree, its root, are you in comp 2, 2, 3, 1? It's right, did you complete comp? Search, have you finished all the assignments? And its left is, did you complete comp 1, 2, 3, 1? We go to the left, and it has all the options. There you go. So everything should be set there. So yeah, that's everything. So in this video, we did a my decision tree. This is the second decision tree. So this is like the one I created. It's just kind of like a brute force kind of setting the nodes. Not use what we're using, because of what a pre-order does. It has a special way to it that like it's kind of like if you wanna, let's say you wanna add, that's like a special way of to something, a function of math. Well, if you have a tree, then you want to do an in-order traversal. It's like a function that's already known. But you can also like multiply, you can divide, you can do different functions with math. You can use like exponents. So we've kind of created our own way here to traverse the tree and set the nodes at the same time. So that's what we did here. I had a way to just, I don't have the diagram, but you can check the diagram and see how I did it. But it's mostly just like set one way and then go back to the parent, then set the left. So set the roots right, I think. Then go back to the root and then set the left and then go back to the right, and then like there's some kind of like symmetry I did that's like it follows the same pattern. But you can do it any way you want. You can like do the left roots first and then come back and do the right roots and whatever. So you can set it up like that. And then here we pick decisions. We made decisions to set up the tree each time we go through add node, that our tree is going to be different. So here we have options to make our tree the way we want, and here we take those original nodes, the original tree that we have made, and we fill the empty nodes and reset the nodes we already did. So if this video helped you, if you enjoyed the video, if you want to see more free educational videos on coding, you can subscribe to my channel if you'd like. And if you'd also like to see educational videos on trading algorithms and investment stuff, anything trading, investment, finance related, you can also subscribe to my channel for free educational videos. And I'll see you guys in the next video. Thanks for watching. Take care.